Title of the first section is Solve Equations and State the number and type of roots. In this section we'll solve equations, and after solving we'll state how many solutions there are, the number of solutions, and the type of roots, which could either be real or imaginary. First question is 2x plus 4 equals 10. Solving a single variable equation, we can subtract 4 on both sides. So 2x equals 6, and dividing by 2 on both sides, we'll get the answer of x equals 3. So solving the question x equals 3, the number of roots would be one answer, and the type is a real number, so this question has one real solution. Second question, and last question for the section. 2x squared minus 5x plus 12 equals 0. This question we have a quadratic equation with x squared. A couple ways to solve this. You can try and factor the equation. This equation does not factor though. You could try to complete the square, or we can also use the quadratic formula. If we use the quadratic formula, we'll have x equals negative b, which would be negative 5, plus or minus the square root, b squared would be negative 5 squared, minus 4 times a, which would be 2, times c, which would be 12. All divided by 2 times a, which would be 2 times 2. Solving from here, or simplifying, x equals negative 5 would be positive 5, plus or minus the square root, negative 5 squared would be 25, and negative 4 times 2 would be negative 8, and negative 8 times 12 would be negative 96, divided by 2 times 2, which would be 4. Simplifying again, we'll have 5 plus or minus the square root, subtracting 25 minus 96 will be negative 71, divided by 4. And the last step to simplify, 71 cannot be factored, or the square root cannot be taken, but since it is a negative, we can take the square root of the imaginary number by putting I on the outside of the square root, and 71 we can leave as positive 71, all divided by 4. So our final answer as a complex fraction would be 5 plus or minus I times the square root of 71 divided by 4. And the last part of the question is state the number and type of roots. Our answer has two answers, since we're adding and subtracting I times the square root of 71. So we'll have two answers. Both the answers do have I, which is imaginary, so we'll have two imaginary solutions. So given an equation, you can solve the equation and also state the number of roots. state the number of positive real zeros, negative real zeros, and imaginary zeros. To do that, we can use three definitions for each one. Positive zeros is the number of sign changes of the coefficient, or less than by an even number. What that means is we'll see the sign changes of the coefficient, or less than by an even number means we'll take away 2 as many times as possible. For negative zeros, a similar definition, the number of sign changes in f of negative x, which means we'll take the opposite of the function, or less than by an even number. And again, we'll count the sign changes and then take away 2 as many times as possible. For the imaginary zeros, those are the remaining zeros that add to the degree total. First equation we'll look at to find the number of positive, negative, and imaginary zeros is f of x equals 5x cubed plus 8x squared minus 4x plus 3. So again, we'll take this function, f of x, and we'll find the number of positive zeros, negative zeros, and the imaginary zeros. For the definition, we'll look at the sign changes. The sign changes are when it goes from a positive number to a negative number, or from a negative number to a positive number. So looking at the first function, if we have positive 5 to positive 8, that's not a sign change, since they're both positive numbers. But if we go from a positive 8 to a negative 4, this will count as one sign change, since we're going from a positive number to a negative number. Also going from a negative 4 to a positive 3 would be another sign change, since we're going from a negative number to a positive number. So since we have two sign changes, looking back at the definition for positive zeros, positive would be the number of sign changes in the function f of x. Since we had two sign changes, we'll have 2 positive zeros. The second part of the definition, though, says it could be less than by an even number, which means we can take away 2 as many times as possible. So we could have 2 positive answers, or if we take away 2, we could have 0 positive answers. We'll always end at 0 unless it's an odd number that will end at 1. But the first part of the answer, how many positive solutions could there be, or positive zeros? There could be 2, or there could be 0. Second part of the question, for the negative zeros, we'll take f of negative x and count the sign changes. F of negative x means we'll plug a negative x in for each of the expressions. The trick when you're solving negative x is if it's negative, if you have a negative number to an odd power, that would change the sign and make this negative. But if you plug a negative into an even power, like a squared power, the negative would cancel out and the sign would stay the same. For example, if you plug a negative in to the cubed power, 3 negatives will change this to a negative 5, and we'll still have x cubed. But if you put a negative in to the squared power, a negative times a negative would be positive, so the positive 8 would stay the same. If you plug a negative in just to the x, that negative would multiply with the negative 4 to change that to a positive 4x. And the constant 3 would always stay the same. So again, you can plug the negatives in for the x powers. If you have an odd number, the sign will change. And if you have an even number like 2, the sign will stay the same. From here again, you can count the sign changes. If we go from a negative 5 to a positive 8, that would count as one sign change. A positive 8 to a positive 4 does not change, and a positive 4 to a positive 3 does not change. So for the negative zeros, or possible negative zeros, since we have one sign change, we'll have one possible negative 0. We cannot take away 2, we'll either end at 0 or 1 solution for these again. So the answer to the negative part would be one possible negative solution. The last part is imaginary zeros. Imaginary zeros add up to the degree total. If you remember, the degree total is the highest exponent. If we have x cubed in the original function, that means we can have a total of 3 answers. Looking at the positive zeros, if we have 2 positive zeros, and 1 negative 0. Those would add up to 3, which will count for 3 zeros or a third degree. So for the imaginary zeros, if we have 2 positive and 1 negative, that adds up to 3 already. So we'll have 0 imaginary. The second option though, we could have 0 positive. If you have 0 positive solutions and 1 negative, together that makes 1 solution, or 1 total solution. The degree though is 3, is how many solutions we have to have. So in that case we would have 2 imaginary zeros, since 2 plus 1 plus 0 adds up to 3. So the possible solutions or possible answers, we could have 2 or 0 positive solutions. We have to have 1 negative solution, and we could either have 0 or 2 imaginary solutions. Next problem we'll take a look at, and next equation, g of x equals 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. And again, from this function or equation, we'll find the possible number of positive, negative, and imaginary zeros. The positive number of zeros, again, look at the sign changes. Going from a positive 2 to a positive 1 does not change, to a positive 3 does not change, but going from a positive 3 to a negative 4 would be 1 sign change. Negative 4 to a negative 1 does not change, but a negative 1 to a positive 9 would be a sign change. So for the positive number of zeros, since we have 2 sign changes, we'll start with the number 2, which represents 2 possible positive solutions. Keep in mind though, we'll take away 2 each time, so we could end up with 0 positive solutions. So the first part of the problem, how many positive real zeros are there? There's either 2 or there's 0. Next part of the question, to find the negative zeros, we'll take g of negative x. And again, you can plug a negative x in to each of the x's and solve. Or the trick, all the odd exponents would change and all the even exponents would stay the same. So if it's an odd exponent, we'll change it to negative 2x to the 5th. And again, that's because we'll have 5 negatives, which will make this a negative 2. And the positive x to the 4th, since that's even, that would stay the same. And again, that would be having 4 negatives, and 4 negatives would stay the same as a positive. The odd again would change. The even exponents stay the same. X would be x to the 1st, which would be odd, so it would change. And plus 9 does not have any x's, so that would stay the same. Once we have the negative function, we can count the sign changes. Negative 2 to positive 1 would change. Positive 1 to negative 3 would also change. Negative 4 to positive 1 would change. And that would be it for the negative zeros. So for the negative solutions, again, you count up the sign changes from the opposite function. In this case, we have 3. So there's 3 possible negative zeros. But again, take away an even number each time until you end up with 0 or 1. In this case, if we take away 2, we'll end up with 1, which represents either 3 negative solutions or 1 negative solution. And for the last part of the problem is the imaginary solutions. Imaginary solutions, again, are the ones left over that add up to the degree total. In this case, the degree in both of the functions is 5, so we have to have a total of 5 solutions. If we have 2 positive and 3 negative, 2 plus 3, that would be 5, which would mean we have 0 imaginary solutions. If we have 0 positive though and 3 negative, 0 and 3 would be 3, so we'll need 2 more to get the total of 5 solutions. And if we have 2 positive and 1 negative, that would be 3 also, which would repeat the 2, so we don't have to write it twice. But the last number, if you have 0 positive and 1 negative, that means we need 4 more imaginary solutions. So 0 plus 1 plus 4 would get you 5. So our imaginary solutions would be either 0 imaginary, 2 imaginary, or 4 imaginary. And last function for this section, h of x equals x to the 10th power minus x to the 8th power plus x to the 6th power minus x to the 4th power plus x squared minus 1. Again, counting up the positive, negative, and imaginary solutions or zeros. The sign changes, if we go from a positive x to a negative x, that would be one sign change. A negative to a positive would be another sign change. Positive to negative, negative to positive, and positive to negative. So each time it is a sign change. So the positive zeros, counting the sign changes, we'll have 1, 2, 3, 4, and 5. So we'll have a maximum of 5 positive zeros for this question. Again, though, we'll take away 2 each time until we end up with either 0 or 1. So there's a possible 5, but if we take away 2, we could also have a possible of 3 positive. And if we take away 2 again, we'll end up with 1 positive. So there could either be 5 positive zeros, 3 positive zeros, or 1 positive zero. Next part of the question, we'll find the negative zeros. To do that, we'll take the negative function, h of negative x. And again, to find the negative function, you can either plug in negative x and simplify, or all of the even functions would stay the same, and all of the odd ones would stay the same. Each of these are all even, so the function would stay the same. X to the 10th would stay the same, x to the 8th would stay the same, all the way down for the entire function. Since there are no odd exponents and the negative one's constant, the function would stay exactly the same for h of negative x. Counting the sign changes. Sign changes again, since the function stayed the same, would be every single sign change, which again would be 5. So the negative zeros, we'll start with 5, since there's 5 sign changes, and again take away 2 each time, so you could have 5, 3, or 1 negative zeros. And last part of the question for imaginary. The imaginary zeros again, in this case, have to add up to 10, the highest exponent or degree. Imaginary will always start at 0, since we'll have 5 and 5, which would be 10, so we'll have a possible of 0 imaginaries. Counting up, we could also have 3 plus 5, which will give us 8 solutions, which means we need 2 more imaginary to get to 10. You could also have 1 plus 5, which would be 6, which means you need 4 imaginary. You could also have 1 plus 3, which would be 4 solutions, which means we'll have 6 imaginaries. Or the smallest number, we could have 1 positive and 1 negative, which would be 2 solutions, which means we'll have to have 8 imaginary. So the imaginary solutions, you could either have 0, 2, 4, 6, or 8 imaginary solutions for this equation. rational zero theorem. If f of x equals a sub n times x to the n plus a to the n minus 1 times x to the exponent of n minus 1 plus the rest of the terms all the way down to a sub 1 times x plus the constant a sub 0, then the possible rational zeros for the function will be the fraction plus or minus p over q, where p is the factors of the last number, a sub 0, and q is the factors of a sub n, which is the leading coefficient in front of the highest exponent. Title of the first section is List the Possible Zeros. In this section, we'll look at polynomial functions and list the possible zeros, which would be zeros for the function. First function we'll look at, f of x equals 2x to the third power minus 11x squared plus 12x plus 9. To list the possible zeros, we'll first find the value of p and find the value of q. Looking back at the previous definition, p again is the factors of the last number, a sub 0. In this case, the number is 9, so p will be 9 and all the factors or numbers that divide into 9. 3 is a factor of 9, and also 1 is a factor of 9. All the numbers that divide evenly to 9. And q, looking back at the definition, is the first number, the leading coefficient in front of the highest degree. So q will be 2, but also the factors of 2, which would be 2 and 1. The possible zeros again will be a list of fractions that we can make with p over q. We'll start off with plus or minus, since it could be positive or negative fractions. Taking the first number p could be 9 over the first number q, which would be 2. So the first possible zero would be 9 over 2. Second value, we can also use 9 over the second value of q, which would be 9 over 1, or just 9. Continuing on, we'll take the following next value of p, which is 3, and list that over both q values, which would be 3 over 2 and 3 over 1. And the last possible zero, the last p could be 1 over 2, or it could also be 1 over 1, which would just be 1. So the list of possible zeros, all the possible fractions, could either be positive or negative. 9 over 2, 9 over 1, 3 over 2, 3 over 1, 1 over 2, and 1 over 1. And again, these are possible zeros, which means some of these are zeros, but some of them are not zeros. And last function we'll look at, g of x equals x cubed plus 8x plus 6. And again, to find the possible zeros, we'll find the value of p and q, and then list out the fractions. P again is the last number, the constant 6, and all the factors of 6, which would be 3, 2, and 1. And q is the leading coefficient, or number in front of the highest degree. In this case is 1, and the only factor of 1 is 1. So the list of the possible zeros, again, each possible zero could be positive or negative, plus or minus. And since we only have one q value, we'll have the values 6 over 1, 3 over 1, 2 over 1, or 1 over 1, or 6, 3, 2, and 1. And again, these could be positive or negative. So we'll have positive 6, positive 3, positive 2, positive 1, but we also could have negative 6, negative 3, negative 2, and negative 1. Title of the next section is Find all of the rational zeros. In this section, we'll continue to list the possible rational zeros, but we'll actually find the zeros that work for the function. One definition for this section: number of zeros is the degree. For any function, the number of zeros for that function is the same as the degree. And if you remember, the degree is the highest exponent for any function. First function and only function for the section: f of x equals 2x to the 5th power minus x to the 4th power minus 2x plus 1. Again, for this function, we'll find all these zeros. Looking at the degree total, we have x to the 5th, so that means this function has a total number of 5 zeros. They could all be rational zeros, or some of them could be rational and some could be imaginary. But for this section, we'll find just the rational zeros, which could be up to 5 zeros. First, we'll list off the possible zeros by listing the p's and the q's. The last number, again, constant 1 would be p, and the only factor of 1 is 1. And q, the leading coefficient, number in front of the degree, would be 2, and the factors would be 2 and 1. So listing out the possible zeros, could be positive or negative, 1 over 2, or 1 over 1, which would be 1. So the possible rational zeros, positive 1/2 and positive 1, and also negative 1/2 and negative 1. And again, some of these will be zeros and some of them will not. To determine which ones are the correct answers for the question, we can take these numbers and divide them into the expression. If they divide in evenly, they're a zero or a factor. If there's a remainder, then it's not the answer. For example, if we do synthetic division, taking our first number, which is 1/2, we can divide 1/2 into the function to see if it works as a zero. The coefficients will have 2, negative 1. There is no x to the 3rd in the function, so we'll have 0x to the 3rd, and also 0x squared, and then negative 2 and negative 1, or negative 2 and positive 1. And again, using synthetic division, we can divide. If there's no remainder for this function, or for this division question, that means 1/2 will be a 0. If there is a remainder, it means 1/2 is not a 0. Dividing, we can drop the 2 down, and multiply by 1/2 each time. 2 times 1/2 would be 1. Adding straight down would be 0. Multiplying by half would be 0. Adding is 0. Multiplying again and adding is still 0. Multiplying by half is 0. Adding this time is negative 2. And 1/2 of negative 2 would be negative 1. And adding, we'll have our last number 0, which means the remainder is 0, which means one of our zeros would be 1/2. Keep in mind we want to find all the zeros, which is up to 5 zeros, or all the possible zeros that work for the function. So we'll continue to do division using the other numbers that we have for p's and q's. For the rest of the problem, if you want to, you can continue dividing the original function, or when we have a 0, we can divide using just what's left over. For example, we can draw another box, use the next number, which is positive 1, and divide 1 using the coefficients that we have left over, not counting the remainder of 0. So the next problem, we'll divide 1 into our other coefficients. And again, if this works, we'll have no remainder, and 1 will be an answer. If we do have a remainder, then 1 is not an answer. Dropping the 2 down again. This time we'll multiply by 1 for each question. 2 times 1, adding 2. 2 times